Owners of an online shop believe their sales can be modeled by this exponential, s equals ab to the t. A and b are both positive constants. S is the number of items sold in a month. T is the number of complete months since starting their online shop. I found this a little bit confusing when I read it, but it's saying that, for example, if T is 1, we've had one complete month. S is the number sold in that first month. When T is 5, we've had 5 complete months. S is the number sold in the fifth month. I feel like it could have said that a little bit more clearly, but hey, that's just my interpretation. The sales for the first 6 months are recorded, and the values of log to base 10s are plotted against T in the graph shown. Explain why this suggests the given model is appropriate. Well, we clearly have something that is close to a straight line, but why does that mean it's an exponential? So for this, we need to take the exponential and take logs and show that it's going to give a straight line equation. So log s will equal log ab to the t, and I can separate that to log a plus log b to the t. Then I can bring the t down, so it's going to become log b times t plus log a. And this is actually in the form y equals mx plus c. So should give a straight line. When plotting log s versus t, and it does. So given model is appropriate. Whereas if you got something that wasn't a straight line, maybe it kind of curved up like that, then it wouldn't be an appropriate model because it wouldn't actually go with y equals mx plus c. Owners believe that A is 120, B is 1.15 are good estimates for the parameters. Show the graph supports these estimates. So let's get a straight line graph fitted. I'm trying to get it through, can't have like the same number of points either side. Actually, it's pretty good at just fitting it. In fact, I'm gonna try and make it go through that first point. All right, it's very good fit to a straight line. There'll be a range of values accepted here, but I can see from my graph that we've got 2.08 as the y-intercept. That's actually going to be log A. So to get back to A, I do 10 to the power of 2.08. Which gets me 120.226, which is going to be very, well, it's basically 120. If you end up getting a slightly different line of best fit, maybe getting 2.09, it's still okay. Don't worry about that. And now I need the gradient. So, okay, this point was 2.08. That point at the top is 2.44. Going along 6. It's good to take as big a triangle as possible to minimize the errors. And I'm going up from 2.08 to 2.44, so that's 0.36. And therefore log b is going to be 0.36 divided by 6, which actually I think gives 0.06. Again, when I originally did it, I didn't quite draw the same line of best fit. I got 0.583 recurring, I think, as my gradient. It's okay. Then this time it's going to be 10 power of 0.06, which is 1.1481. Which is very close to 1.15. Use the model with the parameters that they've predicted. that they've gone with to predict the number of items sold in the 7th month after opening. So this comes back to what I said originally. We actually just need to set t equal to 7. And that will be after 7 months when t is 7. Put that in. So 319.202. Just round that to the, well, nearest whole number, 319. Now use the model to predict the number of months after opening when the total number of items sold after opening will first exceed 70,000. So this means we've got to add some of them up. So this is going to be the total. Constant S is used for the sum, so it's a little bit confusing. Maybe let's total after n months be Tn. So Tn will be the amount after the first month, which is actually going to be 120 times 1.15 straight away. So just be aware of it, because normally you have this as your, well, this is our A, and then it's going to be 120 times 1.15 squared, and so on up to the nth month. So we do have n terms here, it's got to be said, but it's not quite in our form a and a. This here should actually be a times r to the n minus 1. So I can sort it out because I can actually work out 120 times 1.15. It ends up being 138. So I'm just kind of rejigging it to what we're used to with our geometric series. This is quite subtle but important. Then the second term would then be 138 times 1.15. And then the last term would be 138 times 1.15 to the n minus 1. Okay, this is now in a good place because the sum given in the formula book will be a, well, I'll just write it over here, a 1 minus r to the n over 1 minus r. And for us, a is 138, r is 1.15, and n is the number of complete months. So it will be 138 times 1 minus 1.15 to the n all over 1 minus 1.15. And I want to know when it will exceed 70,000. So rather than creating an inequality, I'm just going to set it equal to 70,000, find the value of n when it's exactly 70,000, then we'll go with the integer after that. Okay, so just got to solve this equation. Well, I can divide through by 138. And I can times through by minus 0.15. That gives me minus 1750 over 23, which is equal to 1 minus 1.15 to the n, which means 1.15 to the n is then going to be 1 minus that, 77.0869. What it was it 0869? Yeah. You can either do log to base 10, but you can actually go straight for it and just do log to base 1.15, up to you. If you do log to base 10, you then have to divide by log to base 10 of 1.15 on from the left. $31.088. So that means we are very, very close to 70,000 after the 31st month, but we're not quite there. So actually, it's going to be 32 months. First, or complete months, I should probably say, to exceed 70,000. Finally, we're asked to comment on how reliable this prediction may be. So we know the data is reliable for the first 6 months, but it doesn't mean it's going to be then reliable after that. That's extrapolation and it's always considered to be unreliable. So I said not reliable. So trend, sorry, I went up with actually trend, exponential trend may not continue after t equals 6. I feel like that should be enough, but the mark scheme, they started giving reasons why the trend may not continue. It just said, explain, there's no reason to say that it should, any kind of pattern should continue in the same sort of way. But I suppose if you want to be really thorough here, you should write something down, such as the pattern, the market could become saturated, there could be a decrease in demand or increase in competition. These things are good additions to just saying. But if you say something just like extrapolation not being reliable, then that is another good thing. That avoids giving a reason, about why it's going to change. And there's some other things now as well, seasonal sales and so on. So, okay, just something along those lines for 1 mark. Whether I would have enough, I feel like I should, but mark scheme seems to want a little bit more. Okay, well done.